Hello everyone and welcome to another video with Special Maths Academy. So we're beginning a new video series and we're discussing the problems from the 2023 first round of the Special Maths contest. So let's look at the first problem. It says a slanted ladder X unit long has its top resting on a vertical wall. So let's say we start like this, X unit long. Okay. So X unit long, let's say it's H units high on the wall, and it's the foot of the ladder is W units away from the base of the wall. Okay, so says suppose the bottom of the ladder resting on the horizontal ground is shifted 14 units to the wall. So if we have, so there are two scenarios, two possible scenarios. So suppose the ladder is shifted 14 units to the wall. So of course my diagrams are not drawn to scale. So this would be W minus 14. We're told that the top of the ladder, moves 8 units. Okay, so it gets closer. Okay. And then suppose, so there are two, the second scenario is suppose instead that the bottom of the ladder is, shifted 21 units away from the wall. Okay, so suppose instead we have this. Okay. Then we're told that the ladder will move down 27 units. So this will be H minus 27. Okay. Or you have X. Okay, so we want to find the length of the ladder. Interesting. Okay, so what we can do is we can, start exploring with Pythagoras theorem quickly. So we can have H plus 8 squared plus W minus 14 squared equals to X squared. Okay. And this is also equal to, we can just equate both of them. H minus 27 squared plus W plus 21 squared. Okay. So we can expand things out. So we have H squared plus 16H plus 64 plus W squared minus 28W plus 196 is equals to H squared minus 54H plus 729 plus W squared plus 42W plus 441. Okay, so this is just normal binomial expansion. And then I'll just cancel out some things that on both sides of the equation. So H squared and H squared will go out, W squared and W squared will go out. So let's see what we have. So we have 16H plus, so this will come to the other side. Rather, the minus 54H will go to the left-hand side. So we have 16H plus 54H, and that is going to be equal to 70H. So I'm skipping some steps. Okay. And then we have, so we have 64 plus 196. That's going to be equal to 260. Okay, so we have the left-hand side. So 70H plus 260. Okay. So I've handled 64 plus 196. And then we have negative 28W plus 42W. Okay. So that's going to be equal to what? So when we take the negative 28W to the right-hand side, it becomes, plus 28W plus 42W. That's going to give us 70W. Okay. And now we can look at 729 plus 441. So that's going to be, okay, so let's just do it quickly here. 0, 1, it's going to be 7, 21. So this is going to be 1170. Okay, so let me erase this. Now we have 70H plus 260 equals to 70W plus 1170. So we can, subtract 260 from both sides. So we have 1170 minus 260. Okay. And this is going to be 0, 7 minus 6, 1, 11 minus 2, 9. Okay. So we have 70H equals to 70W plus 910. Okay. So we can actually divide through by 70. So we have H equals to W plus 13. Okay. So H equals to W plus 13. And now we can, try to get uh the value of X. Okay, so let's see. By Pythagoras theorem from the original equation, the original scenario, we have that X squared is equals to what? H squared plus W squared. Okay. So let's see what this can give us. Let's scroll down a bit. Okay. So we can come down to this equation. So we have, let's just say we have, uh, let's consider the first half of the equation. We have H plus 8 squared plus W minus 14 squared. And this is equals to X squared, which also equals to H squared plus W squared. Okay. So we can substitute. Remember, H is equal to W plus 13. So we have W plus 13 plus 8. So that's going to be 21 squared plus W minus 14 squared is equals to we have W plus 13 squared plus W squared. Okay. So let me scroll down. So we have W squared plus 42W plus 441 plus W squared minus 28W plus 196 equals to W squared plus 26W plus 169 plus W squared. Okay. So let me change color. We have W squared and W squared can cancel out from both sides of the equation. And we have, so this becomes like a linear equation in terms of W. So we have 42W minus 28W. That's going to give us uh, 14. So 14W. And you can take it to this other side. So we have equals to, so 26W minus 14W, that will give us 12W. Okay. Now we can look at the constant. So we have 169 minus or 196. That'll give you 27. Okay, so then 27 plus 441. So that's going to give you 468. Okay. So now we can divide both sides by 12. Okay, so this implies that W is equal to, so 12 will go into 46, we'll have 3, remainder 10. So 12 will go into 108, that's 9. Okay, so we have W is equal to 39. Okay, so W is equal to 39. Then we have H, which is equal to W plus 13. So it's going to be 39 plus 13. That's going to give you 52. So we now need to find X squared. So I think that, we could probably do this in an easier way. So this is 13 times 3, and this is 13 times 4. And we can see that for those of us who are already conversant with Pythagorean triple, we have X squared is going to be, so basically no need of, okay, so we have that X is going to be equals to, 5 times 13, okay? Because we have a 3, 4, 5, uh, Pythagorean triple here. Now you can still do it, manually to get the same result. So we have 39 squared plus 52 squared and take the square root. So this should give you 5 times 13, okay, which is 65. Okay, so let's scroll up and see which of the options should give us the correct answer. And that's option A, okay? So I hope you enjoyed this video. Don't forget to share, comment, like, and subscribe, and see you in the next video. Goodbye, everyone.